not remember because this is not part of the midterm exam. It's 2 weeks before that. So pretty much, I'd like to, before we start the SQL, I'd like to briefly review what is the relational algebra and the calculus. Okay. So what is a relational algebra or calculus? Why do we need relational algebra or relational algebra expression? Yes.
Relational algebra to find questions.
Question. What is the question?
Query.
Query. Okay.
Query. Result of a query.
So what is a query? What do you want to get after query? The database. You want data, right? So far, what is the title of this course? It's a database design. So far we have designed the database from the information. So huge information we did modeling. How many different models did you learn so far? How many different models?
Sorry.
How many? We have learned 2 different models. One is ER modeling, another one is relational database modeling. ER modeling, entity relationship model, is good for what? It's a conceptual level design. You do not have to consider specific database, specific application. It's just a conceptual design. So superficial. It's a higher level. Just imagine I need the employee. I need the department. That's it. That is the conceptual design. For that, we have used entity relationship model. There are a bunch of other conceptual modeling techniques. Among them, we selected the ER modeling. Then, that's enough? No, definitely not. Because our goal is to build the database using what?
DBMS.
DBMS? Where's the DBMS running? In your mind? In your head? Or the notebook? Yes, computer. Okay? Our goal is to build a database in the computer. Okay? Unfortunately, computer cannot understand your ER modeling. Okay? Everybody can understand. Human being can understand easily because that is a conceptual level, higher level. But that's not enough to build a database on top of computer. So to address that problem, we selected what? Relational database model, which is based on the set theory. So we got a set of the data as a set or relation. That is a relational database model. Then, what is the main difference between relational model and ER modeling? Why do we need to consider additional different database model? Why? Yes.
Because relational database model built on a set theory that can be transferred into physical
database easily. Okay. Computer, in terms of computer, the relational model is easy to understand rather than ER modeling. ER modeling is good for human being like you, but that's not good for computer. So we need some bridge. We need to bridge the gap between conceptual model and physical database. So we need relational model. Relational model because that is based on a set, so we can easily convert it into the data structure. So that is a relational model. So finally we define the relation. So informally it's called a table. So we can build a database. So based on relational model. So we have the relational database. Then just like suppose that we have the new house, which is based on the relation. Okay? Then the next thing after you build the house, you need to use. You should know what is the entrance code and how I can access the entrance door, how I can access the kitchen, how I can use the bathroom. You should know. Okay? Just like that, in database model is also after you build a relational model database, there should be a way to access data. Then relational algebra and calculus show how to access the data. Okay? So relational first. Relational algebra. Relational expression. What is a relational expression? It's a series of what? Relational operation. So it consists of a set of relational operation. So for that relational operation, what did you learn? First, what is this?
Selection.
Selection. So we have the house relation or table for employee. How can I access the data in employee? By pupil. At that time, I don't want to retrieve or query all the tuple, all the data, but I need some part of it. How can you specify? Using selection. So input is the relation employed, and you can give the condition. That is the select operation. So you can use the selection. And what else for this operation?
Projection.
Projection. You can specify what? Attributes. I don't need the whole information about employee, but I need first name, last name, middle name, initial only. At that time, you can do the projection. Then, as we discussed at the time, output of any relational operation is also what? Relation. Okay? So, that is the reason we can make the relational expression. We can use the output of a relational operation as the input of another relational operation. Also, sometimes we want to give the name of the relation, output of relational operation. At that time, you can use arrow, then give the new name, like the result, R, R1, whatever. Also, first name FIRSTNAME is too long or complicated. I want to rename the output of the attribute as F. At that time, you can use the low operation to rename the attribute. These are how many relations do you need as the input of this operation? How many relations? Only one. Employee. Only one relation for each operation. So this is called unary operation. On the other hand, sometimes we need two relations, two data sets, like for example, union, intersection, minus, division. We need two relations. These are the basic set operations. And also this is called binary operation. Okay? Can you remember that? Even you learned such a set operations 20 years, 10 years ago, 20 years, 30 years ago. So this is the binary operation in relational algebra. Also, what else? Sometimes we can make the Cartesian product. What is a Cartesian product? What is a product? It's an all combination of elements from two sets, two relations. So we can make all parts of the combination of the tuples. Then it will be huge relation. We don't need all of that, so we can specify conditions. So Cartesian product plus select operation name what? Join operation. So join operation R and S and join condition. So we can join two different relations. That is a very, very important operation in relational database model. Why? Because we normalize a lot. So your information will be scattered everywhere, so you need to combine, join, using this one. In addition to that, we learn for the join operation. Sometimes I want all the data left hand side, left outer join, right outer join, and full outer join. Also, sometimes we need minimum, maximum, standard deviation, and summation or the count. These are called aggregate function. So, relational algebra supports such an aggregate function using F operation. Okay, these are the most of the thing in relational algebra. And there is another thing, relational calculus. Anyone who can explain what is the difference? This is the relational calculus. What is the relational algebra? So algebra versus calculus, right? What is the difference?
Calculus.
Are they same? Yes, but different notation. Different way to represent a set. It's the same thing. Relational algebra and relational calculus are, in terms of the output, it's exactly same thing, but different notation. For example, relational calculus use such a conditional way, condition, to represent the query. Okay? So for example, so X by X is the employee whose salary is bigger than 3,000. Like this way. Okay? So relational calculus focus on only the condition, output only. However, relational algebra is focusing on how to access the data. Okay, first, it's the same query, but access employee. Select employee whose salary is bigger than 30,000 and project first name and last name. First access this one, then next this one. But some of you guys maybe access project first name, last name, salary, then access the select using select condition. In terms of the output, it's the same, but relational calculus is focusing on only the output condition. But relational algebra focus on how to access the data. Okay, that is the difference. Yes.
Would you please give us one example?
This one. X by X. X is the employee whose salary is bigger than 3,000. That's it. That's a query. Using relational calculus. However, using relational algebra first. Project. I need the first name, last name, and salary from employee. Then select. Salary is bigger than 3,000.
So it's just
This is a relational algebra.
how to write it.
I already write.
No, it's just like this will give me the same result.
Same result, exactly same thing, but different notation. Okay? So, in terms of query process like this one. Why? Because sometimes I'd like to visit all the room. This one, this one, this one, this one, this one, then next one. Or I can visit this one and this one, this one, this one, diagonally. In terms of the number of visits, it's the same, but in terms of the time, there might be different. It's a performance issue. So, query processor like this one. That is the reason I didn't explain details about the calculus, relational calculus. Instead, I spent most of the time to explain relational algebra. So, that relational algebra will be basis of language, database language. What does language means in computer science? C language, C++ language, C# language, all of them are language. So we need database language. Then what does that mean, language? What is the language? It's a communication tool between you and me. Even though your native, the mother tongue is not English, me, I'm Korean, so I'm using Korean, but we can communicate because of English. So it's a communication tool. It's the same thing. Computer definitely cannot understand what I'm saying. And can I understand machine language? No, definitely I cannot understand. It's nothing but 0, 1. Then how can we communicate? How can you order computer computing something using program language? Okay, that's the only way. So database is exactly the same thing. After you build a database, how can you query the data? You need database language. So when the relational model was proposed in 1969, Dr. E.F. Codd and other colleagues thought about what can be the language in relational database model. At that time, they proposed structured query language. SQL is a very, very well-known language in computer science, but it's different from other program languages. It's called the structured query language. It's a language, so we can communicate with the computer, especially database, DBA. And query language is a purpose, objective. We try to query, retrieve the data. To retrieve the data, we can use the language. For this purpose, we can use other program language, but this is structured query language. What does that mean, structured? Yes.
The flow will go from top to bottom, and it can be nested like modules. You can do it like modules.
Then let me change the question. What is the opposite of structured language? Unstructured. And what are the examples of unstructured language?
The old, like Fortran, like Bobo.
Start and end.
Yes, start and end. In other words, procedural language is the opposite of structured query language. C, C++, Java, C#, .NET, any other. If you have if then else condition or loop or procedure, it will be procedural languages. So when I learned the first time the computer language, I learned COBOL and Fortran. So first we design the flow chart like this. Then convert using the Fortran coding sheet. Probably you do not know the coding sheet. I use the coding sheet when I code the Fortran first time, then give it to the operator, then operator push, plug and push into the reader, that coding sheet, then compile and run. Anyway, so there is a start and end. There are go back and forth, then finally end. What about the structured query language? Database is the table style, tabular form, the relation. Okay? To access, to query such a data, we don't need such a procedure. Instead, we need specialized query language to access this data. So, we consider relational algebra. Using relational operation, we can access the data. So, we convert. Dr. E.F. Codd and their colleagues convert relational algebra into structured language. That is, select from where. Probably some of you guys already heard or knew about this one. It's a very, very well-known form. Select from where? It's everything in SQL. Then, for example, selection. I'd write access employee. Okay? Employee. Where do you get such a data? From employee. So employee from will be here. List of relation should go to from. Any table, any relation will be listed on from. I need first name. Project. First name, last name, middle name, initial. So list of projection will be listed. Actually, in syntax there is no projection. Instead, first name, last name, middle name, initial. Any list of the attribute will be located at select clause. These two are mandatory in SQL. Then, if you want to specify the condition, like here, salary is bigger than 3,000. So select operation will be where condition. Salary is bigger than 3,000. It's a straightforward. Just convert from relational algebra to SQL. So, in other words, if you know relational algebra very well, it's just a piece of cake. It's nothing special. But I know many of the database programmers or developers actually do not know this part and just use very simple select from where. Then they are saying, so I know everything, database. Okay? It's easy to start. However, because of the structured nature, which means it's not very flexible. When you make the very complicated SQL or database language, at the time you should know the structure. Sometimes your query will take 1 day or like 1 week. But the other developer who knows the relational algebra and the database structure will take just less than a second. Output exactly same. That is the difference. So this is the SQL that we are going to cover today. And on Thursday we will have the practice. So half of them are already done. Select from where? Select from projection operation. This is the list of the relation and condition. One more thing is, I'd like to retrieve the employees information who are working for research department. Can you remember that? Relational algebra we already did. At that time we need to join two tables, employee and department. So in case you need to access the two or more, you can list up by separating comma. And you can use the comma for attribute. Also join condition will be located in where close to, like the D arrow is equal to D number. For example, department. Select D name research and join with employee. Okay, join condition is what? D number is equal to D N. Then select first name, last name. That's it. This is a relational expression. How can you make? Select projection. First name and last name. From how many? 1, 2. Employee and department. Where? What is the condition here? D name is research. And join condition, D number is equal to DM. So if you understand the relational algebra, making SQL is just a piece of cake. Very easy. It's a straightforward way. Okay? Then later, when you get experience, you don't have to make the relational algebra because you understand, you know this one, then you can directly make the query. Okay? So, in chapter 4 and 5, especially in chapter 4 this week, we are going to learn basic SQL. Basic SQL means this is the history of SQL. So SQL was proposed with a relational database model by Dr. E.F. Cook at that time. All the researcher, industry, and professor had a meeting. Why don't we make the standard common thing? Why don't we standardize the database query, database modeling? So that is the 1986, which is called the SQL Standard 1. So they make the standard first time. Then after that, there are a lot of the improvement and the development. They make the major revision in 1992, which is called SQL Standard 2. So those who want to develop the new relational database system, like the Oracle Informatics, I developed the Professor Lee database. At that time, I want to use the relational model standard. Then I can adapt this query standard, SQL 2 standard, or SQL 3 standard. After that, there is another revision which adapt the object-oriented concepts or more complicated concepts. But most of the concepts that are currently used in relational database model actually revised in SQL Standard 2, 1992. Okay, that is the reason. If you know one of the DBMS, for example, I know Oracle, how to use them, then that means it's not a big deal. It's not very difficult. It's easy to catch up another relational database management system, such as DB2 or Informatics 1. All of them are using same standard. Their own feature is very small because it's a commercial product. So they try to add. It's nothing but adding new features. It's not a basic fundamental thing. Basic fundamental operation, relational operation are standardized. Okay? So that is the reason I'm not going to teach it very specific, the DBMS model, because they are already standardized. But for your practice, I selected the Oracle database. The only reason I selected Oracle database is it's the most popular product in industry. Unfortunately, from SQL 2003, it's a first edition, first standard. It's not free, which means if you want to use, for example, I developed a new DBMS. So I'd like to use the standard SQL 2003, I should pay to use that. Okay? That is because the major industry, Oracle Informatics DB2, they don't want to share their market to other new industry, new business. So from this, but good news is most of the function that you need to know is already done in SQL 2 or 3. Most of them are in SQL 2. The SQL 2003 are very specialized function, so you don't have to worry about. Also, our lecture and practice will be based on SQL 2, a little bit SQL 3. First, can you access the data without, let me change the question. Can you use the bathroom without building the house? It doesn't make sense. First you build a house, then you can use it. So that is the reason many of students actually give up to learn the database. They download 4 gigabyte Oracle database, install, spend a lot of time, then finally install. Then nothing you can do. When I select the data, you cannot select the data. Why? There is no database. It's that what you guys have been doing so far is just installing software. Okay, it's not a database. It's a database management system software. Then, can you select the data without creating database? Doesn't make sense. Before you select the data, you need to create the database, right? So that is the reason many students give up. I cannot select the data. It's useless. Yes, it's useless if you do not create the database. First, to learn such a SQL, first you need to create the database. So that database is described by what? All the database object. That is called SQL schema. Can you remember the database schema? What is a schema? When we are learning the ER modeling, yes, it's a description. Okay? In other words, anything that you are going to create in this database are considered as the schema. So there are 2 ways to create the schema. So for example, I'd like to create the company database using Oracle database. First, you need to create the schema. Boundary is kind of a boundary. So this is my schema for company database. Then within this boundary, you can create table, index, user, whatever. Because all of these database objects are required to build a company database or to describe the company database. At that time, you can create such a company schema explicitly. For example, here, like the create schema, company, authorization, JSmith. JSmith is username. For example, my username is JELE. You have your own. You can specify your username, which means I'm going to create. Before you create the table, first boundary. This is my lot. Okay? This is my backyard and front yard. Within this boundary, I'm going to create my house. It's the same thing. First, create the schema. It's a boundary. It's my description. Okay? However, when you are using the real DBMS system like Oracle Informix, most of them, they do not create the schema. That doesn't mean there is no schema. No, there exists schema. How? If you do not create the schema name, schema, when your username account is created, automatically create the default schema. For example, the database administrator create my account, JELE, then automatically JELE schema is created. The reason is that usually one user create one database, so there can be schema. So you don't have to create the schema explicitly, but as a default, username will be used. Okay, but using my JELE Oracle account, I'd like to create 2 different databases. At the time, you can create different the schema. Okay, this is one schema. This is universal schema. Company schema. You can create such a schema. Okay? Yes.
Schema here determine one database, so I can with one user I can create 2 or 3 or
yes, you can do that
with different schemas.
But usually one user. It's a recommendation, one user per one database, but it's not a general rule. But you can create the many database schema from one user. Okay. Also, several users can create one schema. But as a default, when a user is created, JSmith will be created. JSmith schema will be created. Then, can you remember very first week? I think first week. What's the second week? We have discussed about characteristic of using database approach. We learned several characteristics. The benefit of using database. One of the reasons why we are using the database is self-describing nature. What does it mean, self-describing nature? Yes?
The database from the starting describes what we have used.
Yes?
To describe everything.
The database. This is my database. Okay? So I have the company schema. So within this company schema, I can create the table, foreign key, whatever. Everything you can create. The information. So which means this database object describes the company schema. Then if you are using the DBMS, this description will be stored at somewhere in your database also. That is a self-describing nature. In other words, using this information, you can get all the information about your database. Like the employee. You can get the employee information from this database. This is called catalog database. So each and every DBMS maintains such a catalog database. The Oracle database that you are going to use has also such a catalog database. For example, when you create the table information will be stored at user underbar tables. This is a built-in table. Okay? In catalog database, this is. There are more than 200 catalog database. Will be created when you install your database DBMS system. So, for example, when you create the employee table information will be stored at this catalog table. The column information will be here, and statistics will be here, and partition information, more information will be stored at this catalog database. These information are good for what? Database administrator. So database administrator actually does not have to ask which table you create. Actually, the database administrator can select such a description by accessing this table. Also, developer, I create a new table, but I forgot which table I create. At the time, you can access this information, then get the data. That is a catalog database. On Thursday, we will take a look at what kind of the catalog table you can access and how you can get such information. Then it's time to create the table. The relation informally is called as what? Table. Relation is table. Attribute is what? Columns. Right? Domain is the data type. So from now on, we are going to use the formal name. No, formal name, informal name. Okay? So I'm not going to say, let's create the relation. No, relation is the formal name in relational model. From now on, we are going to use the DBMS. Okay? So I'd like to use such an informal name. So first, to query the data, we need to create the table. How can we create the table?
Create table.
Command is simple. It's just usually straightforward. When you select the data, command is select. When you create the table, command is create table. When you create the index, create index. When you insert the data, insert. When you delete the data, it's a delete. When you update the data, it's an update. When you modify the table, it's an alter. We are not using the modify. Instead, we are going to use alter. Okay? When you remove the table, we can use drop. Okay? Drop table, drop index, drop something. That is the database language. So first, creating table. Create base table. These are reserved words. All the words used for command are reserved words. What does it mean? Reserved word. You cannot use create as the name of a table. No name of the column. No name of your definition. Okay? Create table. No, you cannot use this. Only reserved word. Then table name. Okay? Table name. Let's create the department. Table name. Then you can give left and right parentheses. Then end with semicolon. So semicolon is the end of SQL command. So every time when you finish your command, SQL command should end with semicolon. Okay? In between parentheses, you can provide what? Just think of a relational model. Department consists of what? Attribute. You can provide information about attribute in between. How can you provide? You need name of column, E number, or E name, manager social security number, and whatever. Okay? Then separate by comma, comma, comma. The last one, you don't have to, for example, address. The last one, you don't need. It's a separator. You don't need a comma. Then, is that all? No. You need to provide one more thing.
Data type.
That is called data type. Why? If that is for human beings, like the neuron, you don't have to worry about the data type. You don't know what data types my neuron use. But this is for computer. Computer definitely cannot understand the number. Think about your programming language. So you can start the C program main function. Then what's the first job? You need to declare your variable, like the int I. Is that all? No. You need to specify data type. Integer I, float I, double I, character. There's no character in the C program, whatever. So you need to specify the data type. It's the same thing here. You need to specify the data type. Good news is database include most of well-known data types used in the other program languages, like the int number, integer, double, float, whatever, and character. It's much more convenient than the traditional program languages such as C, because you don't have to define the array. Just character 1 byte, 2 byte, 3 byte. And even in addition to that, it provides a very specialized, convenient data type. So, first, before we finish this one, let's take a look at the data type. Integer, int, float, decimal. Most of the well-known data types are used in DBMS, Relational Database Model. Character n, what does it mean? N number of character byte, okay? And variable character, varchar. Somebody says it's a varchar, but variable character. What's the difference? Character and variable character.
String and number.
Yes.
When you say character n, let's just say 20, it will be reserved 20 characters. But var character, if you say 20 and you used only 10, it will save 10, not 20.
Can you understand? So character is a fixed size. As soon as you declare the DBMS result, the same size of the data, like the character 10, for example. So character 10, we have two. Variable character 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Lee. I insert the Lee. 3 byte. What about 7? The other byte. Some waste of space. Because character allow when you fix the size 10. No matter what size of data you insert. Less than 10. However, variable character, if you insert the Lee, it will take only 3 bytes. Then I modify, I change my last name. Lee, yes, you can. And 1 more, 2 more, 3 more, 4 more, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 10 bytes. You can increase, you can change it. So it's kind of a maximum size. Which one is? So variable character, you can save space. Actually, not right now, but anyway, you can save the space simply. Also, which one is fast? Actually, the character is fast. Because sometimes this one will be 1, 2, 3, 4, some different space. You need to link. It takes more time. But most of the DBMS use variable character rather than character. Okay? Then, what about the variable character 2? This is your homework. Why don't you find research on the difference between variable character and variable character 2? Okay? Anyway, that's variable character. Also, LOB large object block is for binary data or very large character data. Also, Boolean true or false. Be careful, in database, there's one more meaning. In the Boolean, that's none, not existing. So true, false, or none. And one more thing. I like this one, date and time data type. Do you have the date and time data type in C program or C++? In object-oriented concept, yes, you can do that. You can define object. So, long time ago, when I learned the first time C language, the first project was to decide the number of days. Input is the 2 date. Then compute the number of days. Have you ever did?
Yeah.
How can you do that? You need to consider leap year. Every 4 years. Not every 4 years, not 100. And but every 400 years, yes. But every 1600 years, no. So you need to check just the leap year and leap hour, whatever. So it's not easy to compute. Database provides the date and time as a data type, so you can compute easily the interval, period, something like that. Also timestamp, and also you can create, just like the object-oriented program, you can create your own data types too. Okay? So among them you can select data type for this. Okay? So for example, D number is the number. 3 digit and 2 precision, whatever. But in this case, we don't need the precision. Anyone who knows the eraser?
Here.
Oh, yes. Number or whatever. Rename character 10. Manage the social security number. character 9, and so on. For the social security number, which one is better, number or character?
Character.
Definitely, the character is better. Even though name is the social security number, actually it's not number. There is no sequence. It's like the fixed character. Okay? The problem is, like the zip code 06604. If you define the zip code as the number 0660104, there is no 0 in number. So that is the reason character is better, such a fixed digit number. Okay, then this is the correct the SQL to create the department database. One more thing. Sometimes there are constraints. How many different constraints did you learn in relational model? Primary key constraint and foreign key constraint and non-null constraint. Okay, actually the primary key has non-null constraint, unique constraint. So we can say that is the primary. We will see. So there is a null constraint, non-null constraint. Constraint means this data should not be null. So you can add this one. This is optional. Name, data types are mandatory. But this is optional. So you can specify within one line, separated by comma. Okay? So in this case, the full attribute should be end with semicolon. Yes?
How can we define the primary key? For example,
we didn't define it. So, if you want to define such a primary key, you can specify primary key after the last column. You can specify primary key is the number. It's a straightforward, right? Then, what about the unique? It's a secondary key. Can you remember? There are two keys in ER model. We select the number one as the primary key. What about the other? It's a candidate key. Candidate key still should be unique. So unique D name. One more thing, referential integrity constraint. Foreign key. So what is a foreign key? This one should be in another table. Usually primary key. Okay. For example, manager's foreign key, manager social security number. Refer social security number in employee table. I have a question. So you insert the Oracle database. Submit this query. Can you create a table? Yes, there is no problem. Even though there is no primary key, you can create the table. The DBMS, the SQL is much more flexible than